Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 461, Hamming distance. The Hamming distance between two integers is the number of positions at which the corresponding bits are different. We're given two integers x and y, and we need to return the Hamming distance between them. So in this example, we look at the explanation, we can see the last digit, 1 and 0, they're different. So because the corresponding bits are different, we can increment our counter by 1. And the next two bits are the same, so we don't increment our counter. Now, at the third place, again, the bits are different, so we increment our counter, and the last one, again, they're the same. So our output is 2 because there's two sets of bits the two corresponding bits, the two sets which are different. So we alter again above ours points to positions, but the corresponding bits are different. And we're given some constraints. So how can we solve this? Well, there's something called XOR, and the XOR binary operation basically returns 1 if both corresponding bits are different, otherwise it returns 0. So let me walk through a quick example. We've got 0, 0, 0, and 1, and 0, 1, 0, 0. So the result is going to be, well, if we look if we start from the left-hand side, 0 and 0 are the same, so we just return 0. 0 and 1 is different, so we return 1. 0 and 0, again, they're the same, so we return 0. And again, they're different, so we return 1. If we count all the occurrences of 1, we'll get 2, and that's our Hamming distance. So how can we code this up in Python? Well, let's set our count variable. That's going to be initially set to 0. And we need to now XOR the two numbers. So let's say XOR x, and we can use the caret sign in Python to XOR the two numbers together. Well, actually, let me put an equal sign there. And we want to say while XOR, so while XOR is not 0, so while we haven't reached the last bit, we're going to look at the rightmost bits. We're going to say count plus equals, and our rightmost bit is going to be, all we have to do is check if the rightmost bit is 1. So we can do that using the AND operator, XOR and 1. And if it is, our count is going to be incremented. Then all we need to do is a right bitwise shift to go to the next bit. So we're going to say count XOR right bitwise shift, and we're going to do that shift by 1. And then all we have to do is return the count. That should be our code for this problem. Let's check it works, and we pass all test cases, and it's super optimal. In terms of time and space complexity, because it's a 32, we're dealing with, or we can assume we're dealing with a 32-bit signed integer. We are in the constraints. So the space and time complexity will both be constant. So it'll be over 1 space and time complexity. So I hope you guys enjoyed this video and it made sense, and I'll catch you in the next one.